Do you have any doubt from last class?
No, sir.
In last class, we had just derived till this part about relation between time period, range, and height. I'm defining you one more relation, then I will give you some problem related to this, which is how to relate equation of trajectory with range. As equation of trajectory equals to x times tan theta minus g divided by 2 times of u square cos square theta times x squared. We have range equals to 2 times u square sine theta into cos theta divided by g. If you reciprocal it, it will be 1 over r equals to g divided by 2 times of u square sine theta into cos theta. Now, if I rearrange this equation as x tan theta, first term, minus, we may rearrange this expression as g divided by 2 times of u square. I multiplied sine theta, then cos theta. To get this fraction to be same, just multiply it by sine theta. So this sine theta and this sine theta will cancel out. There is one more term, that is cos theta times x squared. I have just multiplied sine theta in denominator, and to compensate that, multiplied sine theta in numerator. Now, this whole term would become 1 over r. So we can write it as x times tan theta minus 1 over r times tan theta x squared. Now, if you take out common as x tan theta, you will left with 1 minus x over r is equals to y. So this is your final expression or relation between equation of trajectory with range. Is it clear?
Yes, sir.
Shab, is it clear? Okay, just write it down. You all have done?
1 second, sir. Done, sir.
Why? Okay. If there would be a question like this, if y equals to x minus x squared by 10, find first theta, second range, third height, time of flight. So how to approach this problem? I'm giving a relation. Since in this part we have y is equals to x minus x square over 10. So first of all, try to take out x as common. So it will be y equals to x 1 minus x divided by 10. So we may write this expression as this by taking out x as common. Now, if you relate this expression with the above expression term, we had y is equals to x times tan theta bracket 1 minus x over r. Just see in this part, we have x times tan theta outside of bracket, or you will say the coefficient of x is tan theta. Similarly, in this expression, we have only x. So if you equate these two terms, you will say tan theta will be equals to just 1. Is it clear?
Yes, sir.
So tan theta is equals to 1. It means theta will be equals to 45 degrees. Similarly, try to equate this bracket part and this bracket part. So you'll get range is equals to 10. Now we have both theta as well as range. If you put all these values in the above expression of relation between time period range and height, that was gt squared equals to 2 times of r tan theta equals to 8 times h. If you equate these two terms, you will get time period or time of flight. And if you equate these two terms, you will get height or maximum height attained by this projectile. Just equate them and try to find time of flight and range. Shab, is it clear till this part?
Yes, sir.
Good, Mahmuna. If we equate first two term, it will be g times t square equals to 2 times r tan theta. G is 10. You have to calculate t. 2 times r is 10 and tan theta is 1. So this 10 and this 10 will cancel out. So you will get time of flight is equals to √2 seconds. Similarly, if we equate last two term, it will be 8 times h equals to 2 times r tan theta. 2 times r is 10, tan 45 is 1. So h will be 20 divided by 8, or it will be just 2.5 meters. Wahid, is it clear? Now, next is we have to define some more relation on the basis of their complementary angle. So next is relationship on the basis of complementary angle. First, what do you mean by complementary angle? Namuna, just tell me.
Where the sum of two numbers is 90 degrees.
Sum of two number or two angle?
Angle.
Good. Let one of the angle is theta and the other is 90 minus theta. So if sum of any two angle equals to 90 degree, so it will be complementary of one another. Now we have to define relation for time period, time of flight, range, height for these complementary angle. First, for time of flight, as time of flight is 2 times of u sine theta divided by g. T1 is equals to 2 times of u sine theta divided by g. And let's say T2 will be for this complementary part. So it will be 2 times of u sine of 90 minus theta. Sine 90 minus theta will be equals to cos theta. So it will be 2 times of u cos theta divided by g. Now, if you divide these two terms, you will get T1 over T2 will be just tan theta. The first relation for time period for complementary angle. Similarly, if you multiply these two terms, T1 into T2, it will be 2 times of u sine theta divided by gravity. Similarly, 2 times of u cos theta divided by gravity. So it will be u square times 2 sine theta cos theta divided by g into g. This whole term is nothing but range. From this part to this term. So we may write this term as 2 times of range divided by g is equals to T1 into T2, which means product of time of flight for complementary angle equals to 2 times of range by gravity. So just remember these two relationships for complementary angle for this time of flight. Is it clear?
Yes, sir.
You may be asked to define proportionality of product of time period to the power of range. It will be a question like T1 into T2 would be proportional to 1 over R, proportional to R, proportional to R square, or proportional to R to the power 0. So which option will be correct? So you'll say this term. Is it clear?
Yes,
Just
sir.
write it down. You all have done till this?
Yes, sir.
Sure. Now next term is height, as height equals to u square sine square theta divided by 2 times of gravity. So let's say h1 for this theta. So it will be u square sine square theta divided by 2 times of g. And for h2, it will be for 90 minus theta. So you will get u square sine 90 minus theta whole square divided by 2 times of g. As sine 90 minus theta is cos theta, so on squaring, it will become u square cos square theta divided by 2 times of gravity, which is equals to h2. Now using these two relations, we may find first h1 divided by h2. So it will be tan square theta only. Next is, if you multiply these two terms, you'll get u squared sine square theta divided by 2 times of g for the first part. Similarly, u square cos square theta divided by 2 times of g for the second part. If you multiply it by 4 and divide by 4, you will get 4 times u square sine square times cos square whole divided by 4 and 4 will be 16 times g square. Now we may write it as 2 times u square sine theta cos theta divided by g whole square divided by 16. This whole term in bracket is nothing but range. So we may write it as range square divided by 16 is equals to h1 is to h2. Now we may write it as range is equals to 4 times root under h1 into h2. So this is another relation for range using height for 2 different complementary angles. Namuna, any doubt till this part?
No, sir.
Okay. Abdul Wahid, is it clear till this part?
Sir, I had a doubt in one chapter, Unit and Measurement, where this LearnView sent one test on the app. So there was a question: the heat generated in a circuit is dependent upon the resistance, current, and time for which the current is flown. If the error in measuring the above are 1 and 1 respectively, then the maximum error in measuring the heat is. Here only dimensions for two things are given. So how do we find the error?
You have to calculate percentage error. What would be the maximum percentage error in heat depending upon
Yes.
current, resistance, and time?
Yes, sir.
As heat equals to I squared times R into T. Okay. So
Yeah.
I having exponential 2, resistance having exponential 1, and T having exponential 1. So maximum percentage error for this heat will be 2 times delta I over I into 100 plus 1 times delta R over R into 100 and 1 time delta T over T into 100. So as percentage error in current is 1, resistance is 1, and time is 1, it will be 2 into 1 plus 1 plus 1. So it will be just 4%.
But sir, there's no option like that.
So tell me the option.
It is 8%, 6%, 18%, and 12%. Here only they gave dimensions for two quantities, that is resistance and current. They wrote if the error in measuring the above are 1 and 1 respectively.
And what were the options?
8%, 6%, 18%, and 12%.
I think there is some mistake. It would be 2%, 2%, 2% for all of them. Then you will get 8. There is some error in the problem. Okay.
Okay, sir.
Sure, you all have done till this part. Okay. Next is, and the last term is for range. As range is equals to u square sine 2 theta divided by gravity. So let's say R1 equals to u square sine 2 theta divided by g. Similarly, R2 equals to u square sine 2 times theta, which is 90 minus theta, divided by gravity. If I multiply it by 2, or if you expand it, you will get u square sine 2 on multiplication with this 90 will become 180. 2 on multiplying by theta, so it will be 2 theta divided by g. As we learn, or we may have learned, sine for this supplementary angle will be same as it is. So it will be u square sine of 2 theta divided by gravity is equals to R2. Just compare this part and this part, you will say range for complementary angle are equal, or ratio of these two terms will be just 1. Similarly, complementary angle may be of this type. If first angle is 45 minus theta and second angle is 45 degree plus theta. If you again put the value of theta to be this and this in range, you will again get the same result. R1 is equals to u squared sine of 2 theta. Theta is equals to 45 minus theta divided by gravity. If you multiply it, you will get u squared divided by gravity times sine 90 minus theta. Sine 90 minus theta is just cos theta. So you will get u squared cos 2 theta divided by gravity as first part. Similarly, if you find for the second angle, R2 will be equals to u squared sine squared 90 plus theta divided by gravity. So it will be u squared divided by gravity times sine. I've done a mistake here. sine of 2 times 45 plus theta. So if you multiply it, you will get 90 plus 2 theta, which will be again u square sine 90 plus theta will be cos theta divided by gravity. So if you compare this and this, you will get, or you will say range 1 equals to range 2. Is it clear?
Yes, sir.
Okay. So just remember this whole relation for this complementary angle. You all have written?
Yes.
Wahid, done? Now there will be a question like to define kinetic energy from point of projection to the final point. Suppose a body is projected along this path with some initial kinetic energy with respect to this initial velocity. At highest point, it will have only one component of velocity, that is u cos theta. So kinetic energy initial would be half m times u square. Kinetic energy final at its highest point will be half m, and velocity is u times cos theta, so it will become u square cos square theta. Now this whole term is nothing but kinetic energy initial, so we may write it as kinetic energy initial times cos square theta equals to kinetic energy final. Now there will be a question related to this. If kinetic energy of a body during projectile becomes half of its initial at highest point, then find angle of projection. Just put this value in this above relation and try to find theta. Try to solve. Good, ma'am, Mona. In this equation, we have kinetic energy final as half of kinetic energy initial. Put this value in this above expression and try to find theta. If you put this value in this above expression, you will get kinetic energy final equals to kinetic energy initial times cos square theta. As kinetic energy final is half of initial kinetic energy, so it will be times cos square theta. This term and this term will cancel out. So you will get cos square theta is equals to 1 by 2. So cos of theta will be 1 by root 2. So theta will be just 45 degrees. Shab, is it clear? Wahid, any doubt till this part? You all have written? Okay. So this is all about projectile motion, horizontal projectile and angular projectile. Next is